almost lightning talk time. I'm trying to figure out how to add co-power to our two speakers. I guess you're going to have to do that, Andre. You let Alexey and Fritz in. We're going to play by slightly modified The Pearl Conference rules. We have one speaker, Fritz, who's going to go first, and then there will be a short gap where somebody can give an ad if you have anything you need to advertise, some project or anything you're working on. And then we will go to Alexey, who has two lightning talks. I'll gong him after the first one, and when he finishes his second one, we'll have another switch. And at that point, if anyone has an advertisement, just raise your hand and we'll get you turn you unmuted so you can speak. And then we have two videos, and then Andrew is going to give his talk, and then we'll have a chance, one last shot for an advertisement if anyone has one, and then he will finish up the day for the conference. That's where we're going. The other bit that we need to know is there are only 6 of us. We have about an hour, so I can be slightly generous, but at about 4 minutes, we will hear the bell. Did everyone hear that? Good. And then, of course, at about 5 minutes, the gong. Alexey managed to make it back yet? There he is. So, let's get started. Raku conference, even if I'm wearing an old shirt. A very old shirt, but that's unimportant right now. So we have 6 lightning talks coming up. We will have advertisements in between speakers. If you have an advertisement, use the raise hand feature in Zoom, and we will unmute your mic and you can say what you got to say while somebody is getting their slides shared. We have about 4 minutes. Gongs and bells will be coming, and that should do it. So Fritz, go ahead and share your slides whenever you're ready.
Okay, hi everybody. I'm going to talk about Christmas, although the weather isn't quite like that right now here in Switzerland. The talk is about a program which simulates ammonia emissions from agriculture. I'm not going to explain all the details about that. You can, I'll give you some links at the end, which you can follow if you are interested. Common simulation model is used for simulating ammonia production from livestock and emissions from the housing, storage, manual slurry application to the field, and also additional fertilizers for plant production. This amount of ammonia which is emitted by the farms is dependent on many farm-specific parameters. For example, the way the slurry is actually applied to the field. In the left picture, you see a lot of slurry going into the air, and ammonia will be emitted directly into the surrounding air. Whereas in this case, the slurry is applied directly into the ground, and so a lot less ammonia is lost here. Akamon application is a single-page web application to simulate individual farms or do regional simulations from statistical data. There's also a command line application, which is used by scientists at Swiss universities to do national projections, running thousands of individual farms at a time and post-processing the results. And just recently, we added a public REST API, which allows us to integrate the simulation engine into other applications. The Akamon program was actually started in 2007 and then implemented in Perl 5 using Michels as a web backend. We had various extensions going up to version 5.x, and in 2017 we decided to refactor the backend and chose Perl 6 and Grow for that. Most of the backend work was actually done by Jonathan. In the 2018 Swiss Perl workshop, we demoed a Perl 6 backend, and predicted that it will be online by Christmas 2018, probably. We got easily distracted, and Perl 6 became Raku. And so I wrote an article for the Advent Calendar 2020, Raku in the Wild, which mentioned that there was a test version online and that we will be in production by early 2021. Christmas 2021 happened on June 1st. Akamon 6 went into production. Version 4 and 5 are still online for comparison, and they give identical simulation results if you use the same simulation model and also input data. And those are the links if you are interested in more details about that. And that's it already.
Okay, Alexey, set up your slides. Does anybody have an advertisement? Go ahead.
Okay, thank you. So I have 5 minutes to talk about Sparrow. Well, Sparrow in a nutshell is an automation tool written in Raku. It allows one to write various scripts using various languages, but glue all of them together in high-level Raku scenarios, and also to run the same scripts as a command line tasks. So I'm going to give you a practical example of how to use Sparrow in Bash together, or Sparrow and Raku together. So first of all, we need to install Sparrow, which is pretty straightforward, basically just a Raku module. Then you have a command line tool, which is S6 for Sparrow itself. Let's get started with our first example. Let's create a Bash script, which is just echoing hello from Bash into stdout and run it using S6. So obviously we have the same stdout that we echo in a script. Now let's modify the Bash script and see how we could use Sparrow to pass command line parameters, name parameters to this script. So we just modified it a little bit and add config function, which reference a named parameter, which is called language, and run the same task passing language named parameters, which has value Bash. So we have the same output, hello from Bash. So we could even have a default parameters for our Bash script by just creating a config YAML file, config.yaml file, sorry, where we could define default parameters for default values for name parameters. So let's create a config.yaml with a default parameters, which in our case is shell, and run the same task. So we could see output change to hello from shell. Okay, so we could even pass different parameters by just separating them, comma. So all those examples shows us how easy to run just a Bash script using Sparrow and add extra functionality to Bash. So someone is talking. Sorry, yeah. Without adding any extra Bash code. Well, and another really cool feature in Sparrow, we could run the same script, the same Bash script as a Sparrow function. So let's create a simple code example, and we use Sparrow 6 decile, and we could use task run function, which basically runs the same Bash script and pass name parameters to it. So, and we have hello from Raku now. Another cool feature of Sparrow, it's called task check. So task check is basically a special file where you could define rules to check your script std out. You could use standard Raku regular expressions. So in our case, so we define that our std out has to have either bash or shell or Perl or Python or Raku. So we define this check and we run the script, and we could see this std out is checked. So std out matched. Okay. And if we pass, say, basic as a language parameter, so we could see the check fails, and we could have a respected exit code. So another cool feature of Sparrow is called hooks. So I'm running out of time. So as you can see, we have a lot of cool features in Sparrow, and please check all them out in Sparrow documentation pages. I think I'm run out of time. Am I?
That was a 1 minute warning. You still have another minute.
Oh, 1 minute warning. I have just one minute. Okay, cool. So yeah, so hooks allows one to basically run another task from main task. So you basically define another task, and you use run task function that run this separate task from main task. And Sparrow will take care about all these. You don't need any extra bash coding for that, which is pretty convenient. So yeah, unfortunately, I don't have enough time to cover all that. The last, I would say, killer feature of Sparrow is packaging. So after all, you could package things up and just creating a meta file which describes your script or your task. You give it a version, name, and description, and you use S6 upload command to upload a task as a plugin or as a package. And then you just run a web server. It could be Nginx. In this example, this is Caddy, which is I believe written in Go HTTP server, and you serve your plugins remotely, so that someone else could use the plugin on their machine by just referencing the plugin name. So we have a hello language plugin, and we run it. We pass the same language parameter as we did in previous example, and we have the same script in our machine. So all this magic is done by Sparrow. So you don't have code anything. You could use HTTP, HTTPS, rsync, or FTP protocols, everything that supported basically by nowadays modern software systems. And there is a sparrowhub.io, which is basically a public repository of existing Sparrow plugins, which now is more than 200 plugins. You could check them out, you could use them. There is a documentation for every plugin, and it's just ready to run. That's it. Thank you for listening.
Okay, that's it for your first one. So switch your slides.
Right. Yeah, let me.
Start when you're ready.
Yeah. Give me just 1 sec. Let me.
Switching slides. Does anybody have an ad they want to?
Yeah. So let me find another link. Just a moment. Does anyone see my screen? Is everything okay?
You're good.
Okay, let's talk about another birdish things today, which is called bird. Well, bird is a fancy bird, which is basically alternative, which is a tool to check your Linux service infrastructure using Raku DSL. Okay, so again, I'm going to be very practical here. So bird is installed as a Raku module. So you might also need SSH pass if you wouldn't want to run bird against a remote host using SSH. and if you want to supply passwords in command line. But so what essentially what Bird is, you create a rules. So every rule is represented by a function which is pretty self-explanatory. So you might check if directory exists, a file exists, if file has certain number of lines, if file has certain permissions, and if package is installed, so on and so forth. So you have this rules file where you define all the checks. Okay, this is just a valid Raku file. Okay, so let me see if I can rotate my screen. Anyway, so and then you run Bird. So Bird is basically command line for Bird tool. So when you run a Bird, it does two things. So first of all, for every function, it runs underline bash code. So for example, to check that package is installed, it runs yum or dpkg command line. So for Debian, it's going to be a different, okay, and it produces some std out. So we have a list of shell commands, each command for each function, or more than one command for each function. But so at the end of the day, they all produce some output, text output. Yeah, so you could see here. So, and the second step of Bird, so because Bird is built on top of Sparrow, and you remember this task check function of Sparrow, I mentioned it in previous talk. So Sparrow would analyze a std out and would verify and would check the assumptions. So for example, if so we want to check that file has certain lines, has certain lines in content. So Sparrow would go to the specific block and would check that it has specific block which is limited by markers, this and this. Yeah, so we would check that it has hello and Bird lines, so things like that. So, and we have these task checks. So every task checks basically it's either true or false, and we have a verification stage done. And it's really attractive feature because that means Bird doesn't require any software installation on a target host. Besides, it only needs standard things like bash or yum, whatever. Yeah. So because it doesn't do any real checks on target host, it's only produces std out using underlying standard commands and analyze a std out using Sparrow, which makes Bird really efficient because it doesn't require, again, any software installation on a target host. So say you want to verify a remote host, you're not going to even install everything or anything on a remote host. Okay. So, and yeah, like I said, Bird allows you to run, every 1 minute, that's completely fine. Allows one to run checks on local host or SSH hosts. You could even have a host file which basically a valid Raku code that should return an array of hosts, and you could run the same checks on a list of hosts. Okay, and which hosts will be checked individually, but it's going to be done in just the same session. Okay, you could also might have colorful output. I'm not going to show it here, but believe me, it's pretty amazing. So, and so there is a documentation for available function in Bird. Documentation pages. So I've been adding new function constantly. So we have a list of function right now, but I'm probably going to add more functions soon. Thank you very much for listening and watching. if you're interested, feel free to reach me out. I use my last name as a nickname in Raku RC channels or in GitHub. Thank you. That is it.
Any more advertisements while we get our first set of video up? Andrew, anytime you're ready. The next two being actual videos might be interesting to follow the chat. I see him moving, but I can't hear anything.
Hi, I am Bruce Gray, Untitled Online. Reading files can't be this simple. This is how you read files in Raku line by line. It isn't the path.io that is so incredible. That's just a neat shortcut to get a file handle. No, it's this that should not work. Not efficiently, maybe not at all. For and lines. Everyone knows you need a while loop, not a for loop, to read a file. It's a iterables versus iterators thing. Completely incompatible. Let's look at Java. Our task will be open a file bigger than memory, do something with certain lines, stop reading on some condition. So I made a big file. It looks like this. We deserve concise, convenient code for common tasks. Java 8 and 9 added a great lazy streams API. This is very close to Raku. In this file, walk me over all of the lines. No, you can't use a stream in a basic for loop. Stream is an iterator. For takes the iterable. That was very jarring for me. If you leave that beautiful streams API in the approved way and try and mix it with the base language, you lose all the laziness, slurp the whole file into memory, crash, and burn. Lots of languages make it easy to do this by accident. It turns out there is a way in Java, but when it isn't taught as an idiom, takes 2 hours to discover online, needs 3 imports, and ends up looking like this, I won't call it a convenience anymore. Frankly, it left a bad taste in my mouth. Several languages try to give you a shortcut with a for each method, but their lambda syntax is lacking in loop control. I don't have time to delve into the cool bits of clever in the Raku design of lines, like how it enables Unix filter operation, or how dot lines on a string versus dot lines on a file are 2 different code bases designed to produce the same effect, so you never need to think of the difference. There's no time to explain how the sequence class is the genius bridge that closes the gap between iterables and iterators. But because Raku really does make for work with iterators, Raku's loop control and multi-paradigm design give me complete freedom to express my solution however makes sense. So, Common tasks in Raku. More freedom, less choking. Thank you.
Hi, my name is Bill Michels. I'm here to talk to you today about getting started with Raku Regexes. Briefly, I'm a biochemist by training, most recently at UCSF, and I found a need to do some text processing, converting text files from one file format to another. What I'd like to talk about is some resources within Raku, some of the key features of the regexes that I've been able to take advantage of, and hopefully an individual case. As anybody who's attending this knows, the Perl family of languages is synonymous with text processing. For somebody who might be stumbling across this talk, Perl 6 was renamed Raku in 2019. These are the three domain-specific languages that I would like to be using together. SQL languages, Raku, and the R programming language. The resources that I found really useful for me are Damien Conway's talk, Everything You Know About Regexes is Wrong, also a PDF that's available on the web, as well as a talk and slides that are available from Zaucker's ZNet called Wow Perl 6. So let me just cut and try to get you an idea what I was working on. These are the files that I was downloading. This is called an array design format file. It gives the list of this particular micro array and how it's formatted. We come down here, it's columnar starting at page, starting at line 20, and starting at line 2909, we start seeing these DNA sequences over here. And this is really what I need to work on and extract, but I also needed to massage this into a format known as FASTA format. But before I did that, I had to understand a little more about regexes and Raku. And this is just a test file that I was using to teach myself how to do Raku regexes. These are two genes. YW is tyrosine tryptophan, human activator gamma, and epsilon. And if I run these, I can see that, of course, the genes match themselves. These are three different ways of writing matches in Raku, using the match operator in the first two, and then using the smart match operator in the third. I think the smart match operator looks fairly elegant. It's also a little more powerful. You can see here that it's smart enough to know that YWHAG matches a string asymmetrically. But here I was finding that what I was doing was creating an anonymous character class, just using the letters G and E to terminate this, these gene names. And I should be matching two left-hand side values, but I was actually matching three. And what I had done was I had forgotten to use the zeroth assertion, which is the string terminator assertion, the $sign character here. And something simple as that was giving me erroneous results. So what really it comes to me is understanding is that you have to really work as hard as you can within those two forward slashes to get the right code. Here what I'm doing is I am creating a named regex called N1 and doing the same thing, and I find that I can use N1 instead of the anonymous character class. That would be very good if I had something extremely complex. And then I can use the $/ operator to pull out the exact matches. N1 is matching the G, N1 here is matching the E. These are the two 5-letter matches in here. So, and this is how you would match a mixture of good and bad genes using a grep. Now, going back to the file that I was manipulating, I would say I probably would want to do this a little more cleanly, but I've basically just taken 10 one-liners and run them all together. And they're going to run one after the other. And I'm going to try to break those out so you have a good idea of what they look like. Here they are. Capture the columns in white space. Delete the characters after the 30 mirror. Capture gene IDs in the two columns before the 30 mirror. Delete the gene IDs in one or two columns before the 30 mirror. Clean up the immediate regex above by deleting one tab. Taking the next to last a gene probe and making it the second column. This is just really column swapping here. Deleting the single column. Inserting a prompt. We have FASTA format has a prompt on its instruction line. Replacing all the tabs with one space, and then just adding a new line. Now let's see whether or not this is done. We will go back to that file. It's still chugging away. And there it is, it's finished. So started with 33,849 lines and ended with 67,698 lines, which is the correct number of lines to stop with. So I will stop there, and I'll have to say that this is what I was hoping for. This is the FASTA format, and I do want to paraphrase Mr. Churchill here and say that regular expressions are the worst form of coding, except for all those other approaches to pattern-based textual analysis.
Right, so I was going to talk about next years and what I was thinking about the year after this one. So there's a brief history of the events which happened in Europe in the past actually 20 years, which is long history, and it was pretty much good for all those 20 years, but yeah, a couple of years it accidentally stopped. And actually there are two reasons why it was stopped. The first reason is the human reason. Yeah, so we split the languages. And but the good side is that we have now two languages, which is also not bad. The second is the obvious reason. But actually, yeah, so we skipped 2 years of offline conferences, and so probably it's time to return to the normal life. I don't know, actually, this time, many people said that they were afraid to go to anywhere, even this year, if everything stops. So I don't know what people will think next year, but probably if that stops, yeah, people will decide to travel again. So I thought that it would be a good idea to just make 2 conferences and just make it back to back, 3 days Perl, 3 days Raku. So this is the calendar for next August, and it perfectly fits the same dates as like this year, for example. It is 6 days in total, so those of you who like both languages will have to spend 6 days. Well, actually, that's not that bad. So I asked in Reddit about Raku conferences and actually note the number of points. So it's 8 apps, and for the Perl subreddit, it's 23. So that's actually the difference between Perl and Raku, at least in the number of people, which is what we kind of agree with. But yeah, still, I think the reactions are quite good. There are a few reactions like spend some time in the Gaulia's nationalized parts, and like Riga is a nice place to be exhausted in. So why not go back to Riga? So actually, it's kind of the place where everything stopped, and it might be the place where everything continues. So actually, yeah. So I booked those days, and yeah, we can try making something interesting, because those of you who were there in Riga can remember that there was a really nice river cruise. We spent about, I don't remember, was it 2 hours, a bit more, on the, actually it was the biggest available ship in Riga. So yeah, it was a good weather, and actually some people skipped, for some reason, some people skipped this cruise, even if they booked, but nevertheless, we can repeat it. And of course, you might remember there's a Lido restaurant. Well, actually it's a restaurant and pub, and there was a good selection of food over there. So yeah, that's all repeatable, and we can continue next year. So I'm looking forward to these kind of events. So yeah, we'll see how it goes in the future. But this is my plans for the next August. So yeah, that's it for this lightning talk.
To finish up the lightning talks, we have them all the time. Remember, we expect that it's a gateway drug. After you've gotten your 5 minutes of fame, you'll realize you're worthy of a 20-minute talk next time. We expect big things from you. The rest of you, next time out, give it a try. And for conference scheduling, it looks like about June in Houston, the third time's the charm on this side of the pond. Details to come later. And now back to you, Andrew, to finish up for the day.